start off, I'm going to start with why use DAGMan. Simple answer, automation. You as a researcher could sit down at a access point and have a workflow of jobs where job A produces output that is input for job B, and you could sit there and submit it and twiddle your thumbs, watching and waiting, and then, oh, it finally finished, time to submit job B. You could do that yourself, but why? Why not let software do it? DAGMan is actually something provided by HTCondor itself, and it is to execute your jobs in a specified order. Oh, the clicker's got me. Now that we know why you want to use DAGMan, what is DAGMan? DAGMan stands for Directed Acyclic Graph Manager. Now you know what DAGMan is, you totally understand it, right? I assume not. Directed acyclic graph, that is a complicated term, I say. It comes from mathematics and computer sciences. It's essentially a graph of nodes and edges, or vertices and dependencies that have direction. A key aspect of a DAG is it's acyclic, meaning there's a distinct start and distinct end with no cycles. This is beneficial because you can then represent your jobs in a DAG, and you have this distinct start here with this job, follow the flow of jobs all the way to the end, and that is a workflow. Let's go. Here I have what is a DAGMan node. As we kind of said, DAGs are comprised of nodes and edges for DAGMan. A node is made of up to 3 parts: a prescript, a list of 1 or more jobs, and a postscript. We're going to ignore the scripts right now. They add a little bit of complexity. If you're just starting out, you really just care about running your jobs. And the core of a DAGMan node is a list of jobs. Side note here, if you've been to one of these presentations before, you may know a slight difference in rhetoric here. Back in the day, we used to say job, singular, 1, not plural. Why is this? Back in the day when Todd Tannenbaum had his mullet and was doing crazy stuff on some computer in the depths of comp sci, DAGMan only allowed a single job per node. And by single job, I mean we have a sample submit file right here, and we're queuing 100. DAGMan didn't allow this back in the day. This did change many years ago, but our rhetoric for talking about this did not move along with it. While we do allow a list of jobs, 1 or more in a single submit file and a DAG node, it is important to know that DAGMan views this entire grouping as a single entity. It's all in, all or nothing. If one of them fails, that entire list is considered failed. So that is a cautionary tale. We do recommend that you still live with the old behavior of a DAGMan node is a single job. There we go. So here's a simple DAG example. It's my favorite. You'll see it all over our documentation. It's the diamond DAG. So up here we have our DAG file. This is what describes the DAG. This is how you inform DAGMan. This is what my jobs are. This is what nodes I want. This is how you run them, in what order. And then I also have the directory that you might see. So the DAG dir, and you have all the different submit files and the DAG file. As you can see, there's a few different lines in the DAG file. The first 4 create nodes. So we have the ill-named job. Job A runs A.sub. Job B runs B.sub. Job C, C.sub, and so on. These last 2 lines, the parent-child relationships, those create the dependencies between your nodes. This is how we actually create that DAG structure. If we visualize this, we get our diamond DAG. Voila, as Frank would say. DAGMan will run this in that order. Job A will be submitted. hopefully run to successful. And then job B and C will be submitted because the dependency of A has been fulfilled. Once both B and C are done, D will then run. It is important to note, DAGMan wants to know everything ahead of time. You need to know, it needs to know all of its nodes, all of its dependencies, any little knickknacks or special features that you want to use needs to be in the DAG file at submit time. Now that we understand how to make a DAG, how do we run a DAG? Well, we got a couple of fun commands for that. The first one, our old tool, Condor submit DAG. It just takes a DAG file, and what this does is it notices that it knows it's a DAG job, does some stuff, creates a special job to run on behalf of you in the sched. The same thing happens for the other command, HTCondor DAG submit. This is using our modern noun verb tool. It's pretty neat. Here we have our two different outputs. This is running Condor submit DAG and HTCondor DAG submit. What happens when you do submit though? As I mentioned, we actually create a job on behalf of the user that submits a DAG. This is actually running the Condor DAGMan process. It runs in the queue. You can see it when you do Condor queue. And this is what actually runs on behalf of you, submits your jobs, watches them, makes sure things are going smoothly. Another thing you might notice is we make a lot of files. This is a list of files that we produce. This is not the full list of files we produce. You can even opt in for more files if you want. But these are the main files that are produced. And this is what those files are. So I've kind of grouped it into two sections, informational and DAGMan proper files. As I mentioned, when you run Condor submit DAG, we produce a scheduler universe job and that runs in the queue. So it has its own submit file, has its own log file, its own error and output file. They don't really contain much, I'll be honest, but they're there. The main ones that are really nice are these informational files. So this first one is the DAGMan.out. I do kind of hope you don't ever have to go in there. It is chaos, but this is where all the information about what DAGMan is doing is. It's our debug file. If you've ever had the thrill of looking at a shadow log or something, it's very similar to that. The second one is the nodes.log. This is the heart of DAGMan. When you have a normal job, you can specify a log file. This writes events, submitted, executing, terminated. The nodes.log is a collective of all the jobs that are running underneath the DAG. And this is how DAGMan functions. It reads this file to understand, oh yeah, jobs have finished. I need to submit jobs. Oh, something happened with this job. That's bad. And then the last one is this metrics file. This comes out once your DAG leaves the queue or exits. This is a JSON formatted file, and it contains a bunch of useful information. Number of nodes in your file, how far it got, how long it ran, just a bunch of random information. As mentioned before, you can use Condor Q to see, watch a DAG once you've submitted it. By default, we batch up everything, so it comes out in one line, because if you ran Condor Q and your DAG contains 10,000 jobs, you probably don't want to instantly have 10,000 lines without asking. So we have this nice little condensed view. It's all batched up, tells you when it's submitted, gives some counts. Unfortunately, my tabbing has gone off. It has the IDs of stuff that's running. If you do want a non-batched up view, you can pass these flags, no batch and -dag. You don't need -dag to have the uncondensed view, but I like to do it because it shows the node name of the associated job. And it looks something like this. So here we have our DAGMan scheduler universe job. And hey, look, node A is running job 7. Unfortunately, it's just a sleep job. Don't tell anyone we're wasting science, but there it is. Another neat thing for those who do know, Condor Watch Queue also works. These are nice. These are good to kind of see a good little what's going on, see what jobs are running. But a lot of people might want to know, what is the overall status of the DAG? We do have a command for that. HTCondor DAG status. The job ID here, this is the job ID of the associated DAGMan job that's running in the queue as a Scheduler Universe job. And this outputs a lot of nice stuff explaining. So I have my DAG job, I don't want to say a number, but it's running science.dag, that's our DAG file. It's been running for 9 hours, 33 minutes, and 35 seconds. Has a total aggregation of jobs, actual jobs running in the queue or have been submitted. So here we have 148 jobs that we have submitted, 138 have completed, 41 are held, 5 have failed. And then we have an individual node count because there's no longer this 1-to-1 ratio of a node as a job. We needed to split this out. And this has the same sort of counts, 138 nodes have completed, 41 are running. This is split up to say 41 jobs because scripts complicate things, but we'll get there in a moment. We got 100. This tells you how many job or nodes are actually waiting on dependencies to complete. This is also nice. 23 nodes will never run. 23 doesn't seem like much, but let's say your DAG is 328 jobs and it says 327 will never run. You might want to remove your DAG right then. We do also make this nice little line that says only 91.46% of the DAG can complete. And we have a progress bar. As you can see, our little characters, they match up here. I decolorified this. You can tell the difference between will never run and have failed. They're distinct by color. And how much of your DAG has completed so far. This is a nice little way to get a quick snapshot of a long-running DAG. Maybe you can make understandings of what the next action should be. Oh, a node has failed, but 99% of the DAG can still complete. I'll continue on with my life. But, all things have to come to an end. Luckily, nothing ever fails in HTCondor, so you don't have to worry about failure. It's all successful, right? But just in case, what happens when a job fails? Well, a node failure is a DAG failure. DAGMan is headstrong. It tries to make as much forward progress as it can until it can't make any more forward progress due to dependencies. So in this example, we have our diamond DAG. Node B has failed. A has already succeeded since B and C have run. Once C exits, we can't run D. It's waiting on B to finish, but B will never finish. It's failed. So DAGMan will, come on. So DAGMan will write a rescue file. This is a nice little file that basically records all the work that has completed successfully so far. It's just a list of nodes that are done. And this will allow you to fix any issues. Maybe you had a typo in your queue statement or in your executable, in your submit file, and this job failed. You can fix that, resubmit the DAG from the same directory, and it will pick up and it will say, oh, A's done, C's done. Let's try running B again. B runs successfully, hopefully, and then we go to D and we finish. Life is good. Oh, come on. DAGMan, that's the basis of DAGMan. Automating jobs for you, keeping this workflow. If something fails, we'll do as much as we can. We'll write this rescue file, hopefully make it easy for you to make the changes you need to restart up again and not have to run an entire workflow. My 4-node example, not too bad, but we have people like LIGO and Court who are like, yeah, sure, we have 10,000 node DAGs. One fails, you don't want to rerun the other 18,000 that were successful. But But DAGMan does also provide a lot of other good features. The first one, if we go forward, is scripts. As I said earlier, scripts are part of the node structure. What a script is it's a simple executable that will run at a relative time to your nodes in the job. Two main types of scripts, pre and post. Pre-script, post-script. Pre-script, we run that before we submit your jobs for that node. A postscript will run once all the jobs in the list of jobs have exited the queue. These allow you to do a bunch of fun little things, like maybe you want to quickly verify some input before you run your node, or you can actually use a postscript to lie and fake a node success because some exit code of a job is super transient and you don't care about it. It's very powerful. But one thing you should know, DAGMan scripts run on the access point, not the execution point where your jobs might run. That has a couple implications. You can't do this to do neat little set up my environment for my job. That's not going to work. Asterisks, I mean, you might move files that allow your job to run, but whatever. And they should be lightweight. These are running on the access point. You don't want to run 18,000 scripts that are super heavy duty, taking a bunch of CPU, bogging down the sched, making Greg over there angry. If you do have something that's heavy that needs to run on the access point, just consider making it a node. Pretty simple, make it a node, add that dependency, looks similar. Another neat thing DAGMan can do is automatically retry. Retrying nodes, that is a key thing. Because when we retry more than just the jobs. If you have a full node structure, so you have a prescript and a postscript, we run both of those when we do a retry. Another key thing to know is when you have a list of jobs, as I said, we're all in. Even if 99 out of 100 were successful and one failed, we're going to run all 100 again. Just something to know. But yeah, retrying is nice. Oh, it didn't actually go. Retrying is nice because you might have a transient failure and you can catch it and be like, yeah, just try the node again. You can also specify an unless exit. Be like, yeah, retry, but if we see exit 3, we know something's really wrong. Don't retry. We'll fail the node now. Another useful thing that DAGMan has is being able to reuse components, i.e. submit descriptions describing your jobs for various nodes. We can do this with the vars line. The vars essentially creates macros for your submit description that we then use at submit time for the node. So in our Diamond Day example, B and C, they run the same job. They take a country, just a country, but they have the same submit file. In the DAG, we can then specify, oh yeah, B is from USA and C is from Canada because C is for Canada. And when we go to submit the jobs, we actually pass this information along to the submit process. So node B will have USA, let's say 7.log and so forth. While node C will have Canada all up in there. You can also use this to create custom job ad attributes. Something neat you can do. We do also provide special macros that you can use in the job submit files. Ooh, I keep pressing the wrong button, sorry. So you don't have to specify a vars C job equals something. You can just put job in the submit file, and that will actually replace with the node name. So you can add this variation saying, yes, this will be b-cluster.log. That's some complex stuff. We're going to get a little bit more complex because you can actually use DAGs in DAGs. Welcome to the world of sub-DAGs. So sub-DAGs, these are actually specified in the DAG file with a DAG. So we have a sub-DAG external simulation, takes a DAG file, and this could be another DAGMan DAG, could be Quartz 10,000 node DAG, could be anything really. And what DAGMan does is it says, oh, neat, I have another sub-DAG. I will now run Condor submit DAG for you. And this DAG will actually run as its own job in the queue. It'll have its own process, its own files. We know we love our DAGMan files, taking up even more space. But to the parent DAG that runs it, it's just one node. It's actually very powerful because you don't need to know the contents of the DAG file until the DAG is submitted. You can actually create variation on the fly. There are times where you might be like, I have a workflow. I need to do steps 1 through 10, and at step 10, I create a random number of jobs to run. I don't know how many that is at the time I submit my DAG. We can help with that with sub-DAGs. So in the paired DAG, you declare your sub-DAG right away. So that is all fine and dandy. It's kosher with DAGMan. It says, yep, I know all my nodes ahead of time. And then you create this inner DAG file on the fly. This contains all your jobs that you've randomly created. You didn't know that you needed 100, but once you submit it, it's all fine. Like I said, the parent DAG here has its primary DAG, and then here's the sub-DAG, and this is the sub-DAG running all our variation jobs. Like I said, sub-DAGs are just general DAGs, so you don't have to have a sweep of random jobs. You can make whatever complex monogamation you want. There is one more way to use DAGs in DAGs, and that is our friend splicing. So a splice is, unlike the sub-DAG, needs to know the DAG structure ahead of time. And what we do with a splice is when we begin running the DAG, we start reading all of our nodes, all of our dependencies. We get to the splice and we say, oh, we want to incorporate this DAG into our workflow. So we actually read the other DAG file, get all of its nodes, put it in, and then put the dependencies as needed. As you can see in our sample DAG file, we just have A, splice, C. It's just a line. But if our splice DAG is an actual X like this, the final DAG actually looks like this. A goes to the 2 starting nodes that don't have any dependencies, and then the 2 final nodes create dependencies to whatever node that they're already pointing to. This has limitations. Unlike sub-DAGs, it needs to be known ahead of time. You can't, it is not its own node within a DAG, so you can't do fun stuff like you can with sub-DAGs, which I kind of glanced over earlier by mistake. You can't have scripts added to them. You can't do automatic retries. So you might be asking, why use a splice? You might have repeating parts in a DAGMan workflow. This simple example, we have an X. Maybe these jobs, this X is a critical section that needs to run at 18 different points in your complex DAG. You could describe this single X with the same submit file 18 times, or you could describe it once in a DAG file and then splice it in at the critical points.